Good morning. So our lecture today will be about manufacturing process of polymer matrix composites. Our lecture objectives would include to define and describe polymer matrix composites, also known as PMCs. We will explain major open mold and closed mold processes, and we will also discuss other shaping processes, including rubber processing and tire manufacturing. An introduction to PMCs. So, PMCs are composite materials consisting of a polymer matrix reinforced with fibers or particles. Key properties include them being lightweight, high strength to weight ratio, and them having corrosion resistance. Composition of PMCs. They have matrix materials and reinforcements. So, the matrix materials would include thermosets or thermoplastics. And the reinforcements can be glass, carbon, or aramid fibers. The matrix binds the fibers and distributes the load. And this is just a visual of the composition. Properties and applications. They are high specific strength and stiffness, fatigue resistance, and thermal stability. And applications will include aircraft structures, wind turbine blades, and automotive panels. And
An overview of manufacturing methods for PMCs is there's open mold, ones that are simple, low volume production, closed mold processes that have higher production rates and improved quality. And then some other ones are pultrusion, filament winding, and prep reg layup. Um, for hand layup processes, which is the open mold processes, there's reinforcement manually placed in an open mold. Then there's resin poured or brushed on, cured at room or elevated temp. And then this is kind of used for boats or some kind of panels or custom shapes that require an open mold to be used with this resin. Um, the pros for it are low cost and simple tools. However, the cons are it's quite labor intensive as well as there's inconsistent quality. And there are spray-on processes that are also open mold processes, like hand layup, but they have chopped fibers and resin sprayed together into the mold. The chopped fibers and resins, then the resin that's sprayed into the mold or onto the mold surface, and then roller is used to compact the layers. This is used for bathtubs, boat hulls, or vehicle parts, something that needs more compaction for the layers. The pros for it are that it's faster than hand layup, but the cons are there's lower fiber content and lower mechanical properties. So for advantages and disadvantages of open molds, low tooling cost, flexibility in part size. However, the disadvantage it's quite labor intensive as well as the quality variation is variable between parts. For compression molding, this requires a closed mold as well as a preheated charge placed in the heated mold cavity. Um, then there's pressure applied to the form shape. Um, it has a high production rate. Cycle time is between 1 to 5 minutes, quite fast. And then for the applications, it's automotive panels, electrical parts. It has a good surface finish as well as reliability. However, it requires expensive tooling.
Resin transfer molding. Um, we have a closed mold here. Um, Preform of dry fibers placed in mold, and then the mold is closed and sealed. Resin injected under moderate pressure, which then cures inside the mold. The advantages of a closed mold, um, low voids, good dimensional control. The only limitation is that it is high cost tooling. Advantages and disadvantages of closed mold. The advantages we have here are a better surface finish, a higher dimensional accuracy, with disadvantages being a higher tool cost and complex mold design. Other PMC shaping pultrusion. Um, it's a continuous process, continuous pulling of fibers through resin bath and heated die. Products oop, produces constant cross-section parts like rods and beams. Other PMC shaping, filament winding. Um, Continuous fibers wound over rotating mandrel, which then resin is applied during or after the winding. Um, Used for pressure vessels and tanks. Sheet molding compound and pre-reg layup. So we have a SMC, which is a pre-mixed resin fiber sheet compressed into molds. The prep reg, which is a pre-impregnated fibers with resin, cured in an autoclave. Rubber process and overview. Natural and synthetic rubber used for elastomer-based composites. Primary operations consist of mastication, mixing, shaping, and curing.
Rubber shaping methods. One of them, extrusion, continuous shaping through die. Calendering, rubber passed through rollers to form sheets. And molding, compression or injection molding for final shape. Tire manufacturing processes include steps like mixing rubber compounds, forming tire components, assembly on drum, and curing in mold under heat and pressure. Mathematical relationships in PMC processing. First is curing time, which is T equals to K multiplied by thickness squared. Flow rate, which is Q, equals to A multiplied by the V area, which is the area multiplied by velocity. Injection pressure, P equals to F divided by A, and variables affect mold filling and curing efficiency. Advantages of PMCs. High specific strengths, excellent corrosion resistance, it's lightweight, electrical insulation and flexibility in shape and thickness. Disadvantages and limitations. Costly material, carbon fibers, thermoplastics, limited recyclability, environmental or health concerns, styrene and VOCs, and processing complexity, which is the defects. So key takeaways from this is that PMC offers strong, lightweight, and customizable materials for advanced manufacturing. Processes choice depends on part complexity, volume, and cost. Mastery of curing, pressure, and material handling is critical to successful production, and future growth is automation, multi-material composites, and eco-friendly resins. Thank you very much.